From my stage.
Yeah.
You're on stage. Are you our headline act this evening, or are you the warm-up act?
I'm the warm-up.
You're the warm-up act.
He's the
headline. The headliner.
Yeah.
Okay, the floor is yours.
Yeah. Okay.
Does the ink blot have a meaning?
Does the what?
Does the ink blot have a meaning?
Oh no.
So, in the data to ink ratio, that would be considered just noise, decreasing the amount of information per.
And you got some noise on the sides as well.
Yeah, just checking. Accuracy and wearable track.
Yeah.
That's good.
So that's my theme. It's not an easy field because many the algorithms for calculating steps are vendor dependent. Yeah, so I've been searching around and I found yeah, these are some of the devices. I've been searching for some stuff. This article I found very good, and so I will present this article. It's from the UbiComp conference from 2015, so I think it was in September, so it's quite recent. Yeah, so this is the article. When fitness trackers don't fit and users' difficulties in assessment of personal tracking device accuracy. So these guys has taken 600 product reviews and conducted 24 interviews. They think users faulty test their activity trackers, and therefore is not satisfied with their unit. They measured 60% of US adults track at least one health indicator, so it's a popular market. A lot of people are tracking in some form. Yeah, they have studied both positive and negative reviews. They gather the reviews from Amazon, so they have so therefore they have a lot of reviews, and they wanted to have a lot of data, of course, to have scientific yeah. And what they was investigated was also the users' understanding of how the devices work to detect and measure if their data was correct. And they thought users often conducted faulty tests. They found 7 types of problems with how the users conducted their tests. I'm not going to talk about all of them, but because they're pretty related, so I talk about some of them. In the background, and related work, they look at how the pros, the quantify itself. Oh shit! What happened? Okay. Yeah, how they conducted their test, and they found that these guys are more testing their hypothesis, so they're not testing very much for the accuracy of the devices. And I think, or their end goal is for designers and developers to have a better understanding of how the users use their unit and how they test if they're collecting the right data. Yeah, and naturally enough, users were tolerant of errors when they were not doing so much workout activities. But if they were doing a workout activity, they would be very frustrated if they was not recorded.
So false positives are okay.
Yeah.
But false negatives, not so much.
Yeah. Yeah, and they were also aware that the Amazon users was not representing the typical users, and that's why they interviewed the 24 other people. And yeah, they were compensated $20. I guess that's normal for asking them some questions. Yeah, actually 9 of the participants had stopped using the trackers. So that's 9 of the 24. But anyways, they was interviewed, and the condition was they had to use the tracker for at least 1 month. So these are this is the table, the gender, the age, and what device and month they've used the device. Yeah, so there are some a couple of like fuel bands, Fitbit One, Fitbit Flex. I think the Fitbit One is the one you attach to your hip.
That's the one.
Yeah, and the Flex is the one you
on the wrist.
Yeah,
so
on the wrist. Yeah. Yes. So. And what they found that people are trying to work out the inner workings of the device, but often get it wrong. So the user testing, they have divided into two groups: the ad hoc testing and the folk testing, if I pronounce it right. Yeah. So the ad hoc is what they think as just a quick test doing in everyday activity. Just yeah. An example is to check if a movement was detected that was supposed to be detected, or make a movement that should not be detected and check if it was registered. So this guy walked for 30 minutes without moving his arm, and then he sat down and waving his arm for 30 minutes, and he was not satisfied. I think it was a major flaw. And this citation here means he was using the up bracelet. The R means he's a reviewer from Amazon, and he's number 60. Participant number 60. Yeah. And for the folk testing, this is the example. This guy is walking the end of the building and back, counting my steps, and this device only recorded half of my steps. So I think it's bad. Yeah. This guy is running 4 miles, running 4 miles, and then the bracelet said he was running 7, so he's not satisfied either. So I come back to why these measurements are no good, and that's what this paper is investigating. Why are the users measuring this way? Yeah, and this guy, I think this is a girl. She is wearing 3 different fitness devices at once, and just came to the conclusion that none of them was trustworthy. So yeah, also a way to test the devices. Yeah, and so to the problems with the ad hoc testing, they were judging 2 different. This is a girlfriend and a boyfriend with each going on the same trip with the job on up, and it was 3,000 steps off from the one and the other, and that shows how they measure a scale that is specific to its wearer. So because the steps would be different on different people, of course, some with the shorter steps and longer steps. Another problem is that the Fitbit One is worn on the hip and the Flex is worn on the wrist, and this guy I think it's 20% off from those 2 devices, and of course that would be wrong. And the user is not aware that entering the stride length would benefit the readings and what they call calibration. Yeah, but they don't mind that. So that's a flaw in the design almost. Yeah. Yeah, and there's the problem of tracking activity that's not steps. So this guy is tapping it on things, and of course then the steps are not counted, and therefore he thinks, yeah, it's a good device. Because so he's testing it also the wrong way. Yeah. The black box nature. Yeah, because the users don't know how the unit works. They don't they don't know how to improve their reading and accuracy, and therefore find the device less useful. They can't understand how the calories burned was calculated. And one guy was frustrating, burning tons of calories, and I've barely been out of bed. Another guy was playing a video game at evening, and then his unit registered that is as sleeping, so he thinks the time of the day is part of the algorithm for sleep tracking. Yeah, and again, this is the big frustration when you go to the gym for 30 minutes, and the tracker only shows 2 minutes of very active minutes, and then the day after he do no workout, and he got more active minutes. And this is a nice approach also. He sees that the device only counts steps after 50. He's taken about 15 steps, but he thinks that's okay because then it's count his time of being active, and he thinks that's the most relevant in order to get fit. So that's another approach. And here this guy is frustrated. It don't measure the active time as he is bicycling, so he's tried to wear it on his ankle, but then it won't count steps either. So yeah, the user is always trying to find ways to have better readings. Yeah. So this is the conclusion, almost the result of the article. They think the vendors should support testability, allow greater end-user calibration, and increase transparency. And I can easily agree to that. The testability, they think, would lead to better understanding of the true limitation of the device. So if they was given, hold on, I think we get to that. Yeah. Yeah, and by the end user calibration, I think one user might want to count the step walking around the house, while another might not. So that's by calibration their own units, they would count what they wanted to count. Yeah, and this is the increased transparency. They think visualization of movement patterns from a period of time. I'm not sure if this is a good way, but they think the first will you will record some activity and then get some visualization of how the unit picks up that movement. And so they think that will learn the user, and the user will learn how the unit functions, and therefore will be more satisfied and know how to do the right movements to track their activity. Yeah, that was about it, I think. Oh, yeah, it shows the conclusion. Yeah, okay. My screen is... Yeah, so I think this article shows that there's, I think many users are frustrated, and there should be more research be done on this area. The user expects accurate readings for all type of data, because we saw that there was frustrating because the length they was walking was not the same length as the thing was tracking. So the device only counted the number of steps, right? But it also shows the distance you've been traveling. So that's a problem, because if the user sees, okay, I've been traveling 2 miles, then they want that saying to be right. They don't expect, okay, it only measures my steps, then it can't be that, right? I think it's a crappy unit because the number is wrong. So yeah, they are not aware of they need to have a GPS sensor if the distance should be accurate. Yeah, so that's my presentation.
All right. So how is the step counting working inside those trackers? Who knows? Do you know?
Accelerated?
Yeah, and how? How does it work with the accelerometer? What is the accelerometer giving you?
I think it's looking for consistent movement. If you do like this, it's not, yeah, that kind of movement, but I don't know.
So what do you think? How would you do that? You sort of, senior researchers now on mobile. So if someone asks you, okay, can you write me a app which will count my steps using accelerometer, how would you do that?
The question is not. I think the question should not be, can you do it? Yes. Can it make it accurate? No. With today's technology, it's not possible because there's too much noise in regards to movement and, for instance, body height and whether or not you take small or large steps.
Yeah, so you just calibrate it. So I say, oh, I can do experiments with you. I can give you my data and then you do it just for me. How accurate could that be?
Does it use machine learning?
Yeah, you can use some machine learning.
Maybe 50% more accurate, but you can't get it on 100% because the reason I say this is because that accelerometer is also the problem when it comes to tracking in the sense of background noise and movement and stuff.
So the accelerometer itself is not a problem. The accelerometer kind of records pretty accurately of what actually is happening with the device. The problem is that, my pockets are not the same, right? So I have jeans which are very tight, and then the phone is really tight to my leg. And I have sports trousers which are very loose, and then the phone just jumps all over the place when I run, right? So that's the problem is the consistency of use. So the actual sensors are fine, but the consistency of use is difficult. So that's why a lot of trackers opt for the wristband, because that provides sort of consistent behavior, right? So the sensor is always on your wrist and it's always with the same level of tension, and you can have predictable behavior based on that. But like even with the Fitbit One, like sometimes I wear it in the pocket and then the readings are completely different to me wearing it on the shirt. It tends to work better on the shirt, and they say women should kind of wear it, under the bra, and it seems to then be more stable and kind of react more accurately to your body movement. Because if you have it in your pocket or whatever, it kind of reacts more to the trousers movement, not your body movement, and then it's less accurate. It is quite interesting, though, that I also have this feeling that every time I run, because I run with the watch, phone, and this one, and this one says, oh yeah, you run 11 kilometers, which in fact I run like 20. Like, oh, it's a piece of junk, right? I run 20K and it says 11. I mean, come on. But when I walk and I actually run like 15, and that one says 17, it's like, yeah, it's pretty good. So you're kind of happy if it overestimates, and you're really unhappy if it underestimates the movement. Why does it happen? Because as you said, it calculates the distance based on the counting the steps. And I calculated my sort of stride, but of course it differs. If I'm running downhill mostly, my steps are longer, so then the distance is shorter. So it says, oh yeah, you didn't run so much. But if I run up the hill, I'm making a lot of small steps, and then it says the distance was much longer than it actually was. So if I have a run which is mostly uphill, this one overestimates. If it's mostly downhill, it underestimates, right? So what can you do? What can you do to improve the accuracy of tracking? What could you suggest?
Add sensors.
Sorry?
Add sensors.
More sensors, yeah. So there you can put a sensor on your ankles and on your wrists. So 4 sensors. How accurate that could be then? Can you accurately tell what the person is doing? Probably, yeah.
Bigger channel.
Yeah, that would improve the accuracy substantially. Would users do that? Would they wear force sensors? Not really. The thing you talked about calibration is interesting one, because very early on, before the actual activity trackers took the market share, the tracking was done with the mobile phones. So there were apps to do the step counting for you before Google and Apple kind of put it built into the phones. And interestingly enough, the very early apps have had a calibration features. So you could go to settings and you could set the sensitivity of the accelerometer measurements. So you could do a little bit of experiments and you could say, oh yeah, it's always underestimating, so I have to increase the sensitivity. Or it underestimates and I have to reduce it, right? So you could walk around, count your steps, count 100 steps, check what the device is showing. And if the device is showing too much or too little, you could sort of adjust it and you could calibrate it. But those features are kind of gone. You cannot calibrate it anymore, right? People not doing apps with calibration built in. Why? Why do you think is that? When you talked about it, the paper talked about it a little bit.
Will break the algorithms, the machine learning algorithm working there?
Well, if it's used correctly, it wouldn't. It would help the algorithms, right? The problem is people don't understand how those devices work, and they don't understand the calibration process neither. So it's most people didn't use it, and those who use it, some of them misuse it. So they did it the wrong way. So the cost benefits of adding those features in turned out to be not that valid. And it's easier if the machine learning algorithms try to do their best without user fiddling with the extra noise or extra information. But you could calibrate them, and you could use machine learning algorithms with the user feedback to actually improve it. So if I run for a while and I count my steps and I tell the algorithm, well, actually I counted the steps and it's ground truth. The ground truth is 250 steps, right? Then the algorithm could use it to improve itself. Same with walking, but there is a lot of factors which contribute. Device sensitivity is not the one which is the most important. The most important is, different placement of the device, different behavior of the person doing the running, because I can run really light, kind of without a lot of impact, and I can run with a lot of impact, same as with walking. I can kind of do it really smoothly, or I can do it with quite high impact. A lot of pedometers work by the threshold mechanism. So they have, if you combine X, Y, and Z axis into a single value, single kind of impact value. So while you walk or while you run, the shape will be kind of sinusoidal, right? You'll be having kind of acceleration stepping down and with the peak, and then you'll have the reverse motion, right? So you'll have kind of a sinusoidal movement. And what they do, they kind of have a threshold, and they say sinusoidal movements or any movement below the threshold, we don't count as steps. And then if you have impacts which are above the threshold, we will start counting as steps. And they basically set the threshold for you. And with the sensitivity setup, you could manipulate the threshold for yourself and for your shoes and for the behavior that you're doing. Yeah, it is an interesting area. Do you think the accuracy of the device is kind of the main issue here? So a lot of users feel the device being inaccurate is kind of a major issue, but what do you think?
It is because mostly people tend to believe their devices and they're frustrated if they don't get
And
the.
they buy them to work.
So yeah.
Yep. So that is true. But is it more important for you to know that you walked, I don't know, exact number of steps today and exact number of steps tomorrow, or is it more important to you to know that you worked less, 20% less tomorrow than today? The ratios between the measurements, that you less active this month than you were last month, and you cut your activity by 50%. Would that be a more important information for you, or the exact number of steps would be more important? Or you kind of more interested in trends, changing trends, that you're working out more or you're working out less?
For me, it would be like more on the energy consumption, in the sense that I had, like you said, with training, I have a train more or less to.
Yeah.
For me, it would be to get the statistical data of whether or not, if I train, for instance, say every day 1 month and just every other day the second month, to see if, and then just like look at my notes to see whether or not I felt more in shape after training the whole month or just every other day.
Yeah.
And then compare it to what the, for instance, Fitbit or whatever says that my training activity should be.
Yeah. So for most users, the exact accuracy of the device is secondary. What's primary is the consistency of the device measurements. So if there is a consistent bias and consistent error, that is kind of not too bad, as long as it is consistent, that it doesn't vary. Because then I can do the comparisons between months or between weeks in a meaningful manner, and they give me kind of a meaningful results. But if the device is not accurate and inconsistent, then it's pretty much useless, right? Because you cannot really compare yourself to last month statistics anyway. So then it's just a gimmick. It doesn't actually fulfill any function. Maybe motivates you to do some things, because it kind of provides a bit of a feedback loop. And Hugh talked about it a little bit as well, and that is sort of an important aspect, that the cognitive aspect of wearing a tracker, that something is measuring what you're doing, so it kind of motivates you to do more than without a tracker, right? There have been a number of experiments, for example, of people taking notes. You don't necessarily need to use a high technology for that. You can just use a low technology solution. But for example, if I ask you to log every time you're watching TV, right? Just record it in an Excel spreadsheet or on a piece of paper. Chances are you will cut down watching TV, like procrastinating and sitting and watching TV, because every time you do that, you actually have to log it, right? So same as I will ask you, okay, every time you eat unhealthy food, please log it, right? You naturally will kind of cut down eating unhealthy food, because you will feel every time you log it, you will feel, But if you don't have to log it, then you don't care. You care less, right? So the act of being kind of recorded, even if it's not used for anything, even if, at the end of the experiment, you just toss the paper to the rubbish bin, right? Just the act of logging something makes you think about it and makes you change your mind about certain activities. So that has been used for food and so on. There was an interesting experiment of people, like an experimenter asked people to just photograph all the meals they eat, right? Just the act of photographing. They gave them the cameras, which actually didn't work. It was just a fake camera, which didn't took any pictures, right? And asked them for a month to take photos of everything they've eaten. And after the month, they asked them whether they've improved their eating habits. Of course they did, right? Because every time they've eaten something they considered unhealthy, they felt a little bit bad about it, and then they avoided doing that, right? So they were, they thought they were taking photos. In fact, they were not taking any photos, and the photos were not used for anything. It was just a kind of a psychological trick to make them think of what they eat. Yeah, so that the aspect of activity tracking is an interesting one. There was a comment that a lady stopped using a tracker because they became pregnant, right? Why? Why would you stop wearing a tracker because you're pregnant? Why would you do that?
Probably because he was seen all these TV shows where they sit on the couch and eat with potato chips. So
I know, but that's how it is, right?
No, maybe they think it radiates something.
Okay, yeah,
that
that might be a valid argument, but then you have your phone, you have your watch, you have all of those other things. Anyway, I mean, people don't stop using their phones or watches because they become pregnant. So, yeah, but my dad is a little bit like that as well. Like I ask him why you're not wearing your Fitbit, but he says I'm not doing anything. Right? He uses it to record when he's actually walking out and working out and doing things. When he's lazy, he doesn't like the Fitbit to know that, right?
Yeah.
So he puts it on the shelf, and then for a week he's just lazy, not doing anything. But yeah, I found it a bit weird because I never thought about those trackers this way, right? I always thought about them as being on me all the time and kind of telling me when I'm lazy and when I'm not to kind of show off when I'm just not lazy, right? Yeah. In fact, yeah, there was a note also in the paper that someone went to gym, and after 1.5 hours in the gym, the Fitbit or the tracker told him, yeah, you had 2 minutes, 2 active minutes, right? It often happens to me because I have a Fitbit on my shirt, and then when I go to gym, I put the shirt on the bench, and for like 90 minutes, it tracks completely nothing, right? The other one in the paper was someone did the experiments, and they said, I counted my steps, and the device always gives me half of what I counted, right? So how do you count your steps? So when you walk, you say 1, 2, 3, 4, 5, or do you say 1, 2, 3, 4? How do you count your steps? That's kind of a tricky question, because normally for running, you actually count the cycle. So you count how many times your right leg hits the ground. You don't count right leg, left, right, left, right, left. You count right, 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 right. You actually count the kind of 2 steps cycle. That's 1 step in kind of running terminology. But most people count all those, right? So they count right, left as 2, and then right, left as 4, right? So how do you count steps?
Every step.
Every step, right? Exactly. Maybe the device was counting the running steps, right? And the running steps is the cycle. So, you have to finish the cycle. You have to finish the right leg hitting the ground. Yeah, so there are some challenges, and there are some issues. Most trackers actually count every step now because most people don't use trackers for running. They just use them as kind of a common thing for every step. All right, so that's our first talk. So who talks next? Okay, do you want a short 5 minutes break before?
Sure.
Yep. So let's have a short break and then we will resume. You're too heavy? That's a very insensitive comment. So any other interesting things you guys learned this week?
Oh, really? Another time we have a report for the advanced course in web technologies.
Okay.
And it's already late.
Yeah. So what are you doing for that?
I'm doing metadata in the cloud.
Mm-hmm.
How it's used in cloud computing.
Okay.
Many pages. Many pages of writing.
15.
Yeah.
How many?
15.
15.
It's a ballpark. 10 to 15.
Yeah.
Somewhere between that. It's getting hard since we're supposed to challenge the current knowledge and propose
Mhm.
better solution. It's hard to do that when you don't know enough about it.
Yeah.
And it's 5 credits and we're supposed to write a survey.
Mhm.
It's hard.
Is there any page constraints on the report for the mobile?
Nope.
No.
The more the better, generally.
It really works when people talk a lot all around.
That's true.
Not
Yeah,
to the
that's
point.
true. We're discussing it with Simon, like whether there is good amount, which is the perfect one, and then more than the perfect one is not so good, but less is also not so good. So there is always a distribution which has the sweet spot for the questions and for the answers. Yeah.
Because there's a phrase, I didn't have time to write a short note, so I've written a long one.
Yeah.
Which, yeah, is true, right? And it's like, so for example, we're like the whole questioning thing that we're doing at the moment. I'm trying to work out what is a good minimal set, right? Because asking what's a good question. So we've been harassing you guys about this for a year now. And now I'm going to be doing it at a conference, and I'm going to get the participants to grade the other questions that are asked. And I'm looking at giving points, right? Because, you know, we're gamifying stuff. And this is a points gamification rather than a role-playing gamification like my animal models are. And I'm trying to make it simple. And of course, the challenge then is you're not getting full coverage. But is it better for it to be more complex and have full coverage, or to remain simple and therefore have people actually do it? Right? So I'm currently on 4, though Bruno gave me another one, which I might have to add. Okay, so I've got 2 positive and 2 negative. Can you pick my 2 positive things for a question and 2 negative things for a question? At a seminar or at a conference or at a lecture.
And it's all related to quality of a question.
So what's it? What would be your main 2 positive quality indicators for a question? When someone asks a question, when would you think you say, oh, that's a good question?
You have to reflect on the answer. Thinking.
You as the person presenting, or you as the audience?
It depends on the person answering again.
Well, okay, so one of the ones that we come up with fairly regularly is relevant. Right? So a question has to be, like, how relevant a question is a measure of quality. Right? Because I could ask you a really good question that wasn't relevant to a talk. Right? And that still wouldn't be a good question because it's irrelevant to the current discussion. Right? So we decided relevance was something people could measure as well, right? For saying that's an irrelevant question to that's a very relevant question, right? And people are pretty quick at thinking, yeah, that's relevant, or I don't get it, right? The other one I was using was interesting. It's an interesting question. And I think relevant and interesting is being independent, right? Because I'm trying to find independent measures. So I'm not measuring the same thing multiple times. I'm trying to say, because you're a principal component analysis, a minimal basis functions over a diverse set. If you can find the absolute minimal way of representing the greatest variance. Do you know what a principal component analysis is? Have you heard of it before? Okay, I'll very quickly do, because, you know, this is university and we'll talk about weird things. Okay, so principal component, and I think principal component analysis is...
Can you use the other whiteboard? Then I can record you.
Okay.
Thanks.
So a very quick introduction to principal component analysis, because it's a useful way of thinking about what you do, okay? So if I have a bunch of sample points, which you guys can't see, if I have some other sample points, which you might be able to see. Okay, so if these are all my positions, and I have that's a space of data points. Okay? Now, to capture the variation of these data points, this axis doesn't necessarily capture, because it says, well, they range from here to here on this axis, and they're like,
Do you want a different table?
kind of a bit more in the middle and a bit like, so they're kind of like that, right?
Yeah, but
So it doesn't really capture the data very well. So what a principal component analysis says is, well, actually, if we look at all that data, can we find the axis that gives us the maximum variation, right? And in this case, we go from here to here, and we say that axis there gives me the absolute maximum variation, right? So that's the principal component of that data set. And the next one is probably at 90 degrees to that, right?
Okay.
That then captures the next amount of variation in that data set. And the idea is, if you have a very, very large data set, right, with too many potential parameters. So here, I've got 2, and I've tried to give it kind of down to 1, and just saying, well, actually, your measurement along this axis is the most important variation you have. Right? It's more important than the variation on this axis, or the variation on that axis, because it doesn't capture as much of the actual variation of your data. So when you're trying to reduce the number of features you've got, you try and find your principal components and say, that's what's interesting to me. Right? So if I have 2 questions, and we have like
how much
weight
does
and
the
height,
prototype count in
okay,
relation
and
to
you find that
research
this would be weight and height would be
they
something
kind of
like that, right?
are independent. So if you
So-
mostly did the prototype,
Yeah.
then
So
you
weight and
have to
height
develop
are
research.
dependent
But
on
if
each
your
other,
prototype is very small,
but
then you
just
have to
knowing weight
counterbalance it
doesn't
with
really
this.
Yeah, so like
capture
into 3 to 5 reports or
like the interesting variation in the population, and
Research
height
report.
doesn't really
Yeah,
capture
then
the
you kind of more research.
BMI
So then it's more like a review.
is
because
a
the
principal
issue
component
is that I
analysis
figured out
across
which I
weight
didn't
and height
think about
that
or
is
know
useful
about
for
until after I did the
measuring
measurements,
fitness, right? It's not
because
good
parents
fitness.
and I went around
But
measuring rooms.
It's
Is
trying
that
to remove,
the
to take that down to a single
variable
number, right?
from the
So you're now on a
default
single
example
array
material
rather
code
than
is
2.
5.
Yeah.
So
And
if you have
the
questions
average in basically lies between 2
like
to 4 on all the rooms.
insightful
Right.
So I
and
can't actually
engaging
use that
as to
that
measure
much. So
something,
but what I did find was that the BSSID
they
is only identical for
overlap
2 corners,
in some
which
way,
is
right?
the
So if you
rooms close to each
if
other.
this was
So what I'm
insightful
considering now is trying to look
and
at
this was
do the math and
interesting,
look at it. But what I was thinking was to just
or
the
insightful and
BSSID
engaging, say,
for that room you're in, and then take the mean
is
average
there an
of the corners
interesting
and see if
kind
it
of
can correlate
shape
to,
like this,
for instance,
where you
if
could try and find
you're
something
at
and
3
call this line
and
interest,
it's between and one room is 2.5,
right? Which
and
is
the other's 3.5,
because
then I would assume you're in the
an
2.5 because
insightful
it's
question
closer to 3 than 3.5.
Yep.
probably has to be
So-
engaging.
Yeah, that's okay.
Yeah.
So
Right?
if you
So if
you
there
could
is
repeat some of the
kind of
measurements
some
Yeah.
correlation
And that
in your
might
answers
strengthen
between those
the
two
prototype
things,
testing.
then maybe
Yeah.
there's a principal
But
component where you could ask
it's sort of,
a single
as I
question,
said, it
which would
depends how
extract
much you want to describe
something
the
about
prototype
the
and how much
combination of all these other
experimentation you did with it
Yeah.
versus how much you
So,
want to do
the
the
principal
review.
component analysis, you
Because
do
the
that with
issue is
data,
I have,
and you can
if I
actually
do
do
it
it
on a weekday,
algorithmically,
there's
right?
more
You just
people in school, whereas if I do it on the
data.
weekend, it's
So, I
a
was
long
thinking
lecture, so it's like
relevant
the time
Yeah.
it takes to
and
do the
interesting.
measurements and
because
Okay.
I can't
Yeah,
find a
sounds
single
good.
principal
Yeah.
component that measures, that is an interesting measure of the two of those, right? And I believe that it is perfectly sensible to put questions in each of the 4 areas of those axes. Okay, so down the bottom, not interesting, right, and not relevant. Top corner, interesting and relevant. Up here, relevant but not interesting, right? Okay, so I mean, the question is very much about the topic, but it's not an interesting question about the topic. And over here, interesting question, just not on topic, right? So each of those, I can imagine a question that would fit in each area that is something I could describe as, yes, that's of this type and that's of this type, right? So that gives me 2 independent positive axes. And I think of them as positive axes because on relevance, so a completely irrelevant question is a 0, not a negative number, right? Because once you're irrelevant, I don't care in which direction you're irrelevant. Once you have 0 relevance, you have 0 relevance, right? It's not like the question actively becomes worse as it becomes less relevant. It's not, because in another area, it might be a good question. It's just their irrelevance for this topic. Okay, so I think of relevance as being 0 to positive. I think of interesting, an uninteresting question is 0. You gain nothing for uninteresting. I don't think you make me stupider by asking a question. I might accept negative interest questions where that question is so bad it has made the next question worse, or something. You know, so I think of those as 0. So those are 2 positive axes, and the 2 negative axes are longer than necessary and confusion, right, or confusing, right? So those are both negative axes. So you get 0 if you are the right length, and negative if you are longer than necessary, right? And the longer you are, the more negative I go, right? The longer than needed to be. And confusing, if you are crystal clear, you get 0 points, because it doesn't make your question better just because I completely understand it, right? It still may be an irrelevant, uninteresting question that's perfectly clear. So that doesn't add positive to the quality of the question. All clarity can do, or lack of clarity, is make a question worse. So I think of that as being a negative axis, and length as being a negative axis, because shorter isn't necessarily better, but too long is bad, right? So I'm thinking of those 2. Runa added an extra one. So Mariusz added one, which was answerability. Is the question answerable in the time frame allowed? And Runa added important. Is it an important question? Which may not be interesting. I can imagine important questions which aren't interesting or aren't relevant, right? But you know.
No, that one is related to what we discussed about the impact. What does it have an impact to one person, or a field, or entire, society?
Yeah. So how important is this question, right? So is it important to me as the person asking? Is it important to the audience of this presentation, or is it important for the whole society? Right. So we're also. I was also wondering, like, do you give people instructions on when they think about a question or when they think about presenting? Are you asking a question because you personally are interested in the answer? Are you asking a question which you think the audience would be interested in hearing the answer to? Or are you asking a question which you believe the whole of society needs an answer to this question? Right? So how important is your question? And is it you, the group, or society? And the same for relevant. Is this relevant to you? Is this relevant to the group, or is it relevant to society? So each layer may actually create a different answer as you analyze deeper what you actually think about the question that was asked. But the problem is, if you do all of that work and you give people, 15 things to grade per question, they're going to look and go, and it destroys the experience. So that idea of minimizing what you ask and minimizing the complexity, so you can actually get people to give you a response quickly.
But there is actually a lot of interesting research reports on Stack Overflow, for example, where they have reports on predicting which question will be closed, which will be marked as duplicates, and the definition of asking good questions, for example.
Yes, which is why you're doing your masters. I want that you go desperately.
It's actually included in the research questions.
Yes. So you know, I'm not just like posting that there as kind of, oh yeah, that would be something that would be nice. I'm truly feeling desperately interested in getting the result of what makes a good question. And yes, they do have a prediction work on what will be closed and what will be duplicated, and they're trying to find all those things. And what gets voted well, right? So there's a bunch of analysis that can be done and you're going to do on Stack Overflow basis. This is on a different arena. So I'm going to do this in a conference and specifically ask people to give a response. And I think I might only be able to do 4.
Yeah.
Right? 2 positive, 2 negative.
But you should record the sessions anyway.
Oh, you need to record the sessions.
Doing it post-mortem as well.
Yeah. So what do you think those 4 are interesting, or would you want to add importance as a 5th? And do you think 5 is too many things to think about?
I think that when it comes to importance, it's more of a field-specific thing than a general thing, because you may ask a question that is important for a large group, but if it's in the interest of the general population, that's, for instance, can I find?
It's orthogonal to quality, I would say as well.
It is so weird. So quality. So if we're measuring quality of questions, is importance and answerability orthogonal to quality of question? As in, is it something you would add in to a single number? Right? Because those two, I'm multiplying relevance and interesting together, and I'm multiplying short, like length and confusion together, having these are the large negative number, these are the large positive number, adding them all together to give me a single number, which is quality. Right? So a high quality question that, do I need importance of that question to be in the quality measure, or can I say that's really well asked, important, or that's a really good question about an important thing, or that's really good question about this a specific trivial and unimportant thing. All right. So when you think of quality of a question, is importance core or is it orthogonal? So yeah. But anyway, so yeah. If you guys have a feeling and we have a thought, I'm going to be trialing this with a whole bunch of learning academics at a conference, and then the next day here at the Information Security Conference with KPMG sponsoring it, the questioning competition. So we're doing this live. So if you want to help out and like get some data for your thesis, that would be great. So yeah, and it will be different questions. They won't be coding questions, but they'll be just generic questioning kind of and evaluation. But yeah, okay. Internet of other stuff. I've had called it in New Zealand Internet of Stuff rather than Internet of Things.
Good.
Today I'll talk about Internet of Things.
Yeah, we're odd in New Zealand.
There is a definition I found in one of the papers, which says that Internet of Things is an interconnection of sensing and actuation devices, providing the ability to share information across platforms through internet. Yeah, you can read it yourself. But basically, a lot of words. But Internet of Things is a distributed system in a sense. It includes a network of sensors and actuators that collect data. Also, it includes a layer that processes and analyzes this data and stores this data. And also, it includes user interaction layer. So basically, applications using mobile phones, desktops, and etc. to manage Internet of Things or get data from Internet of Things. And of course, the transportation layer. So all the protocols and communication mechanisms used in Internet of Things. This term was first used by Kevin Ashton in 1999 in field of supply chain management. This is a Gartner hype cycle for 2015. As we can see, Internet of Things is on the peak of expectations, and it says that it will take 5 to 10 years to adopt market.
Yeah, gamification on the way down. Yeah, it's halfway down the down slope of the, oh my God, it's terrible.
And we are in AR too. So
Hmm?
we are in AR too. So
Yeah, the VR, AR, gamification, all the stuff that I used to do was they're all cool and upcoming is now.
Now virtual reality is on the up.
It's coming back up again.
Yeah, augmented reality is still sliding down, but the VR is getting into the
Which I thought was a bit odd because last year they had VR right at the trough,
right.
while Oculus Rift was being massively hyped.
Yeah.
And so Gartner has trouble because it doesn't cope with the fact that things happen in waves.
Yeah.
So this doesn't present that kind of waves of wind like
And
hype
ripples.
cycle. It says there is a hype cycle, not
Yeah.
rippling hype cycles. But yeah.
Actually, there's a hype cycle test, especially for Internet of Things. I don't know if it's
There,
for every part of every dot in this hype cycle.
yeah, people create hype cycles for different things. So there's a hype cycle so people have done hype cycles for education, and people have done hype cycles for Internet of Things, and done hype cycles for gamification. And so people will do they'll create a model of a hype cycle and then map shit to it and hope. There is no, I mean, this is a guess.
Yeah.
One group's guess.
So this is a schema of structure of the Internet of Things. So we see different layers, and all of them are connected using secure connections, and yeah. So this is the structure. The first layer, which is wireless sensors networks. It includes sensors and actuators, and for example, smartphones are also considered a part of this layer. Their features are that they're small, they're cheap, and they are low powered and resource constrained, and they're functional, like a single sensor is functionally constrained. So pedometer and accelerometer collects only one type of data. All these devices are connected into a network, which also has some features and requirements. So VSN hardware, WSN hardware is just a circuit with some transistors and that supports collection of data. It also has to have communication stack to communicate with other nodes and with the cloud, for example, or gateway. It also has to have a middleware, which is basically supporting a service-oriented architecture, and also secure data aggregation, not SATA. It's enabling security in these networks. I have link to different, or you can see different sensors. There are a whole bunch of them, and they are really cheap. There are also sets of sensors, and yeah, they're pretty cheap. Also, all of those things that are devices, they mostly support lightweight wireless communication because they're resource constrained and they can do a lot. There are such protocols like constrained application protocol, DTLS, that enables security in COAP, 6LoWPN, UDP, and etc. Also, most of the papers are read about communication Internet of Things. They propose to use RESTful paradigm and RESTful architecture and APIs to because it's much easier to use them with such type of devices. Because it's just basically HTTP requests and responses, and it's much easier for such devices. Also, there is an open source operation system designed specifically for low constraint devices. It's called Contiki OS. Yeah, it supports lots of stuff, and I actually cloned it. It's pure C, and we can see some examples. Yeah, I don't know. For example, UDP protocol. Yeah, everything is organized in threads and processes. And yeah, so this is the example of, if I can do like, yeah, that's better. Yeah, I can comment and say a lot about these because I haven't had a chance to try it and to, but this is still an example. They don't have any GUI because this OS is deployed on a single device that doesn't have anything to display user interface. Yeah. Also, another layer is data processing. This is a scheme of an Eka cloud platform. I found it in a paper from Indian researchers, and all the mentions I heard about, I've seen about Neka is from either India or China. So this is not very popular platform, but still it gives some view of how the platform works. So basically, it accepts. I don't know actually why they included in their Aneka hybrid cloud some public clouds. It seems strange for me, but still, they have data from sensors. They process it and analyze it, and then just send it to the user. Yeah. Also, there are some clouds from Google as well, Oracle, IBM, and there are some requirements for those clouds. They have to be scalable because Internet of Things is a system that grows rapidly. There are a lot of devices added to it, and clouds have to support the scalability. They have to be high efficient and productive. They have to have modern analysis tools, machine learning, neural networks, AI, etc. And they have to support a variety of communication mechanisms. Yeah. This is Google Cloud. Google developed a separate protocol for Internet of Things. It's called Weave. I will show it a bit later. So all of the clouds that I found, they basically the same. They support big data and BigQuery. Yeah, let's see what is BigQuery. So they support big amount of data, which is critical for Internet of Things. Also, you can see that Google Cloud Platform gives us a 3 terabyte of cloud storage each month. It's for security, all the stuff that is needed for the Internet of Things is supported in almost every cloud. IBM actually provides some tool to play with their cloud, but I couldn't connect there. It gives an error. Yeah. User interaction. So this is a user layer where it's either a mobile, web, or desktop application that interacts with the user, where user can see statistical data structured in a user-friendly way. And it should provide smart management functionality to, for example, if we are talking about smart home, the user has to manage this environment. Also, it can be some automated management system, for example, if it's ventilation or something. The cloud has to have some algorithms for automated decisions, for making automated decisions, and send those instructions to the user, which is automated. There are some applications for smart home from Apple, Project HomeKit, Project Brillo from Google, and Wigvac that's a third party. There are some videos about it. Thank you.
Automation is what you can call it, basically. HomeKit is what will allow you to wirelessly control your home and tons of things that are in it. Now, while it was first introduced in 2014, with the announcement of iCloud supported in 2015, HomeKit and compatible products have really seen to pick up steam, with a lot of them expected this fall. We're talking security systems, thermostats, lighting, and more, all controlled from your favorite iOS devices. Want to turn off the lights in the kitchen? Grab your iPhone. How about an iPhone smart plug with your TV connected into it? Use your iPad. Apple is planning to change the way you interact with the things in your house every day with HomeKit. With iOS 9, Siri plays a very big part in that. Now, what Apple is calling proactive intelligence is what we can call, hey, my iPhone is learning what I do every day. So let's say when you wake up in the morning and your alarm goes off, the lights come on with it. Your morning playlist begins on your Bluetooth speaker, and you're just kind of sitting in your bed like, wow. Philips Hue lights, Nike garage openers, even Schlage door locks are among just a few of the brands on board with HomeKit products already. And with the ability to control all of these devices in-home with devices like the Apple Watch, with the expected release of a new Apple TV at this year's iPhone event, this should suggest the ability to continue using the Apple TV as a smart hub for controlling HomeKit devices remotely. So with the smart home controlling your favorite iOS devices with a decent product line already behind it, and with iOS 9 this fall, Siri will give us even more control, and overall with HomeKit, we're one step closer to living like the Jetsons.
So basically, it's just using an iPhone as a remote control to your house, so nothing smart or sophisticated in the system, and there was nothing said about this HomeKit in this year presentation, so that's not very interesting. Yeah, let's watch Project Brillo. This is an actual.
Which is the underlying operating system for the Internet of Things. Brillo is derived from Android, but we've taken Android and polished it down, hence the name Brillo. This is basically the lower layers of Android, the kernel, the hardware abstraction layer, the real core essentials, so that it can run on devices with a minimal footprint, things like door locks. Because it's derived from Android, you get full operating system support. Things like connectivity, you have Wi-Fi, Bluetooth Low Energy built in, and working with Nest, we are adding support for alternative connectivity like Thread, so that there are low power wireless solutions as well. We've thought about security from the ground up, and given it's based on Android, you get immediate scale. Many device manufacturers can use it. In addition, we provide device manufacturers can manage it from a centralized management console. They can provision these devices, they can update them, and so on. So it's an end-to-end functioning operating system. The next step is what we call as Weave. Weave is the communications layer by which the Internet of Things can actually talk to each other. You need a common language, a shared understanding, so that devices can not only talk to each other and to the cloud and to your phone. So what we are doing is we have standardized schemas. Schemas are nothing but a semantic blueprint for all these devices to have a common language. For example, a camera can define what does it mean to say take a picture, and all devices around it can understand that. A door lock can define lock and unlock as two phrases which all other devices in that ecosystem can understand and work off each other. So we will have standardized schemas, developers can submit custom schemas, and we will have a Weave certification program to make sure anything that is Weave certified can work together. Weave is available cross-platform, so you can use this as a modular approach. You can have Brillo and Weave together, or you can run Weave on top of your existing stack. And the powerful thing is Weave exposes developer APIs in a cross-platform way. So if you're writing a recipe application on your smartphone, the actual application can now turn on your smart oven, set it to the right temperature, right? And any connected device, your oven can be voice-enabled easily because we provide voice APIs as part of this. The final thing we are doing is getting the user interface right. So because this is built into Android, any Android device will recognize other device based on Brillo or Weave. And as a user, you get the same standardized setup for any connected device. You open up your phone, we detect it, you choose the device and set up the right owners, and you're good to go. So this is the beginning of a journey. Just like we've done Android for smartphones, we are doing this for the entire ecosystem together. Brillo goes into developer preview in Q3 of this year, and we're going to announce documentation throughout the year, and we are working with developers, and the full stack will be ready to go by Q4 of 2015. And so we are very excited that for the first time, we're bringing a comprehensive end-to-end solution, and we hope we can connect devices in a seamless and intuitive way and make them work better for users. You've heard us talk about how the phone is enabling a multi-screen world. You've heard about other form factors like Android Wear and connected devices, and how the phone is at the center of this digital experience. Now, we want to talk about how we as Google, we are improving the experience on the smartphone. To do that, we go to the core of what Google set out to do. Our core mission is to organize the world's information and...
Yeah, I'm not sure that they will talk more about your things. So basically they call all that stuff a smart home, smart room, oven, whatever. But actually it's not so smart. You just use your mobile phone to remote control stuff. And yeah, nothing smart in that. And also Wigwag, they just have a beta now. They got money from Kickstarter, and they just released in the end of August their beta. And this is also basically the same as the HomeKit, just a system with a bunch of boxes that you buy, and they're compatible and then connected, but nothing smart in that. So that's all.
Okay, thank you very much. So what do you think it would take to make it smarter? What those companies are missing?
I don't know, a lot of research on how to analyze that data, how to get more out of it, the maximum.
What do you guys think? So is the Internet of Things just about, you know, turning things on and off from your smartphone? What else?
Well, the general idea when I learned about it was that it was the ability to communicate with everything, everywhere, all the time. Being able to, for instance, lock your home, set on the coffee maker to start making coffee while you are getting prepared for getting dressed or whatever, and stuff like that.
I don't know, having a scenario, for example, where you're on a vacation and then you get a notification on your phone when that your house is flooded, and it shows you data that the temperature is going down, and then the ideal situation that this system will take decisions and manage that situation by itself.
Mm-hmm.
But I haven't seen anything like that. So having the trend where people want to control more and do less and automate everything, this has to be a very good technology to have.
But it doesn't have to be a good technology. You already have, for instance, these automatic systems that control the electrical, that control the air condition. When it comes to stuff like this, it basically boils down to just writing an extensive code base that can cover more than just, for instance, the garage gate or the door lock or whatever. I don't think it's that advanced, really. It's more about the abstraction of the operation for the different items.
Any other ideas? So if we have devices and sensors and so cheap that we can put them everywhere, you know, around the house and then your day-to-day products and so on. What is possible? What's not possible today? So the term Internet of Things, indeed, as you showed, was about communication between those devices, not us being able to turn things on and off, right? So Apple and Google kind of, especially Apple, is kind of taking a very different approach to this, because having kind of an open protocols for those devices being able to talk to each other, that's the kind of underlying idea. So they can do things together which are not possible by individual components. But that is quite hard to think about, and that's quite hard to design because you have all those sort of emerging behaviors. So you may have simple rules for an individual device, for example, for a temperature controller, which senses the doors and which senses the movement in the house and so on and so forth. And then you will have kind of an emerging behavior of the house, which comes out of those simple rules. But that's not a single company controlling it or a single app developer controlling it. It's kind of more about the interaction. It's about having some sort of conversations between those devices. And that's quite difficult to pre-design or pre-control up front, right? And none of those companies seem to be following that path, mostly because it's difficult to control and difficult to monetize on it in general. You can create a smart light bulb and you can kind of start selling it today. And you say, yeah, there is an open API. You can connect to the light bulb, and you can turn the different colors on and off, and you're free to do whatever you would like with it. But the bulb itself is pretty dumb. The bulb doesn't do anything. It's the same with the door locks. It's the same with everything, which is under the Internet of Things umbrella. But that's not the idea, right? The idea was that those devices are smart. So the smart light bulb actually is not that smart. It's just dumb light bulb with an API to it. The smartness has to be somewhere else. But where will be the smartness if not in the light bulb, right? So that is kind of a puzzle a little bit, because yes, the premise of Internet of Things is great. The underlying concepts are great. The technology is doing quite the opposite. The technology is just doing sort of not non-smart things, because that's easy. That is easy to produce a light bulb to which you have an API. It is actually difficult to produce a smart light bulb, because what does that mean? What that smartness is about? Yeah, we've been discussing a couple of scenarios with Simon, for example, that you can have a bulb here turning green if we in the office, and then if we're not in the office, it's red or whatever, right? That would make that light bulb smart because it would kind of convey through, autonomously some information to you, to the people in the lab. But that's, yeah, how to achieve that, how to sell kind of a smart solution which is integrated already to a market which is so diverse. It represents some sort of it's not a technology challenge, it's more of a business model challenge of how you actually do those things in the market.
In China, they have a solution to create a robot that will do all the stuff, but it will also run all over the house. Maybe that's the way to do that.
Yeah. So, well, we don't know the answers yet. We don't know how to marry the technology with the use cases, business use cases, and how to propose smart solutions. And as with the previous talk with the sensing, we know sensing is quite error prone, right? If I have to have my coffee machine turning on and off itself based on some sensors, well, I may have a lot of time coffee made where I didn't want it to have it made, and I may not have it made when I actually wanted to have it made, right? So there is a lot of potential for misinterpretation of what the patterns are. So safer for companies is, well, the user will turn the button. When the user turns the button, the coffee is made. But that's stupid. I can just turn the button on the coffee machine, right? Why would I do that from my app? Well, that is stupid, but maybe it leads to some apps then building some smart solutions on top of those APIs, right? So the initial use cases are a little bit dumb, but it opens up the possibilities. Yeah, so.
But in theory, if you have a very pattern-strict person, and you use AI, which is potentially more intelligent than it is today, which could learn the patterns that every day at 8 he drinks coffee, every day at 4 he comes home and drinks coffee. Yeah. So after a given set of time, you will have a data set that could be used to interpret to say that if I make coffee at 8, you will drink the coffee. If I make coffee at 4, you will drink the coffee. And then adapt to the person's natural routines, which will make it intelligent, whereas it still fulfills the simple purpose of just making coffee without making it at the wrong time.
Yeah, I know, but okay, let's take the coffee situation, right? So let's say you almost regularly drink coffee, right? So sometimes you wake up, 7:15 and you drink coffee at 7:20. Sometimes you wake up at 7:25 and you drink coffee at 7:35, right? So you have a cloud of data points. You never drink coffee exactly at 7:30. But based on the data cloud, it may average that on average you drink coffee every day at 7:30, right? but you never actually in your life drank coffee at 7:30, right?
Yeah, but okay, stretching it even further, then if the system can detect whether or not you're awake, then it can predict.
Exactly. Yeah.
So it can be aggregated with the accelerometer, for example.
Exactly.
Yeah.
So, but that requires quite a smart solution integrating over a number of devices, right?
Yeah, but not necessarily, because if you integrate that with the Fitbit, presuming that the technology is better than it is as now, which basically goes for all technology in this setting. Well, if the Fitbit says you're awake, and then you know that in approximately 10 minutes you will be ready to drink the coffee, have the coffee ready in 10 minutes because now the person's awake.
Yeah.
So it's not only the the Fitbit, but also a time, and then Fitbit, and then has to be a lot of data and different types of data to make an agreed solution.
Yeah, but if there's a sensor in the coffee maker that records that the button is pushed on, for instance, say that you have a week where it gathers, just a week where you have to do everything manually to gather the test data, then it registers that, for instance, the person is awake at a given time. 10 minutes later, he pushes the on button. And if that's a general between 8 and 10 minutes, then you can estimate that they will drink coffee at the earliest 8 minutes after being awake.
Yeah. So, but you still need to know that the person is in the house. So the Fitbit might say, "Oh yeah, Mariusz woke up, but he is in hotel," right?
Yeah, but then comes the sensor that tells whether there is a person in the house.
Exactly. Yeah. So you need at least three, right? Yeah. So you need the coffee, the Fitbit, and some sensor in your bed or in your house saying, "Yeah, actually, he woke up in this room."
And of course, there needs to be a sensor that identifies whether the person is a human or an animal.
Well, you can be
dog. It's like if the dog is sleeping in your bed, then
yeah. But there is also a risk that, okay, if the coffee machine always makes me coffee at 7:30, I will start following that habit. I will actually start drinking coffee at 7:30, right?
Yeah.
But for that, I don't need a lot of smartness. I just need a timer in the coffee machine, right? So yeah, if you use all this technology and all this smartness solution to just make me coffee always at 7:30, maybe that's kind of ridiculous, right? So I don't know. I mean, there is quite a lot of research work. There is quite a lot of technology work going into it, and I love it. I mean, I think it's fascinating and it opens up a lot of possibilities. But at the same time, there is a lot of tech done for tech's sake at the moment. There is nothing really useful, right? Even with the smart bulbs. I mean, they're cute and they're great, and they are potentially very useful. It just didn't happen yet. It's a little bit of a preliminary sort of exploration of the space of what is possible. Yeah, but we will see. So, yep. So thank you very much. So